Good afternoon, everyone. Hopefully having a good time here at Kong Summit. That email survey, if there's anything bad, do not put it in the survey, just email me personally. If it's good, put it in the survey. That's how I get my pay rise. Today, you're here to learn about what's new in Kong Gateway 3.0. You've got double trouble, myself and Guanlan. I'm Michael. I'm the Director of Product Management at Kong. And Guanlan?
I'm Guanlan, so I'm the Director of Engineering. I run a few gateway teams, who is in leading the effort to get the 3.0 development. Yeah.
Awesome. We've got a packed agenda for you today, kind of split into 2 parts. The first part, more business-oriented products, like what are the flagship features, and we'll do a couple of live demos so you can see them in action. And then I'm going to hand it over to Guanlan to do an architecture deep dive, like how does this stuff actually work? For Kong Gateway 3.0, we had a lot of flagship features. There are 9 on this slide. There are more. Today, we're only going to cover 4 of them. Secrets management, open telemetry, the new router, and Kong Manager 3.0. You may have noticed this little crab up here. This is because the new router is actually written in Rust. And if you know anything about Rust, you know that means we get some internet points. The great thing about being written in Rust is we can generate bindings for all kinds of languages. You may have seen Coco announced yesterday during Victor's developer keynote. Using Rust enables us to use the new router across multiple runtimes, both the original Lua CP and the new Coco CP. The router is the first thing up, but I'm going to hand you over to Guanlan to walk you through it.
Yeah, so what's his router? So any of you play with Kong know what the router is. Essentially, the router is help you to redirect which part your upstream should go to, and why we need a router by the first place. Let me actually ask a question. Like when we're doing the design here, how frequent you're going to upgrade your router configuration? Like any rough guesses? How frequent you change your configuration? Day, twice per week? Anyone?
Every couple of days.
Couple of days? Yeah, that's the wrong assumption we made when we designed the old router. We say, come on, like you're gonna only update your router once per day or something at maximum. So we highly optimize for the router runtime. What that means, like when you try to rebuild router, we're gonna build a gigantic router together. In that case, it's like you can have very fast route matching time, but like we trade off the kind of router rebuild time. That's how it started, but once the cloud native and the Kubernetes kick in, we're gonna see the routers getting upgrades much frequent. For example, if we have something change on the server discovery, the Kubernetes, they will trigger a router rebuild, and we're hurting our performance so much. That's what we think about. Oh, maybe we still think about the wrong assumption we made, right? Like, what if folks need to change router in very high frequency? And the other scenario is like the router numbers, right? Before they say, oh, okay, we are serving like hundreds of router. That's probably good enough. But in production, we'll be able to see tens of thousands or 20,000 of router. Like they're using router they're actually using a program to generate the router because they are such a complex scenario to using. So that's why we're introducing our new routers. The new router come with, so first is writing Rust. I will show you a cool demo. The other things is like we are introducing a router with the incremental rebuild. So in that case, the router, they were building only when you have things be changed. We're only going to build that incrementally. All right, so also is like we're going to reduce cardinality. Also think about you have a lot of complex matching logic, right? So the regex we use a lot. Like most of us biting by the regular expressions, right? Because it's very expensive, and it's hard to get right. And that's we're using for router before is we use tons of regular expression. But within the new router, we introduce a DSL, which is you can think about it like a small language with very good syntax, can almost reduce most of the regular expression. Actually, let me show you the exact syntax, what the new DSL approach looks like. So on the left side, you can see there's 2-point series. We have this indicate the protocol, mask, host, and blah, blah. But in the 3.0, you can actually do is you can embed it like some simple language to make it more expressive, right? So I want to match the HTTP or HTTPS. Okay, you can write in like any other language, and you can also do the prefix matching and like post-fix matching. You want to matching some headers? Of course, you can do the header in your new DSL. I will give you like a little bit more details on this. By writing a new router, we're not only doing the hash table, we're also using the tree-based data structure, so which make the indexing much easier to do. If we have like multiple redax tree, you can get into searching for the tree roots to the node. You can have a way much faster. It's not ready yet, but like this make it possible. All right, business benefit, change route rebuild. When you're changing the Kong configuration, the runtime will not hurting that much when you're constantly changing router, and they've been reduced P99 from 1.5 to 0.1 if you have like 10,000 router. That's almost like a 10x of improvements on the P99 latency. Also, like the routing language, you can, as you can see from the previous example, you can handle much more complex routing requirement. In our talk, I will give you a small demo. All right, so that's the demo we have like for the front end. Because we use Rust, actually this front end is completely built using the backend code which compiles to Wasm. So in the Wasm, we're actually able to using JavaScript, just call the Wasm. And you can see from this demo here, if you change like command, you can dynamically getting to know which syntax error. Oh, you're probably expecting an end op, so they will indicates what's went wrong, right? So if you put here, like let's say full bar, they will generate the AS tree, as you can see here. Those are the condition. If you can see matching pass equals bar. So we are building an AST tree. It's essentially a syntax tree. We were using their parse for the backend. So same library, use both front end and back end. The good thing about this is like you can do the verification of the runtime. So we try to introduce and also get this into our Konnect UI and also Command UI. In that case, you can have even more intuitive when you configure your router. So that's the front end demo. And let's go to the back end to see how it goes. So first we're going to do is like we're going to create our services using HTTP as backend. Okay, so as you can see, it's 2.1 created. Next one, what we're going to do is create a route. As you can see here, the route where instead of using the headers, using this kind of like map style of the 2.0 syntax, we're actually using the route expression in this case. Let me actually show you like what's going on here. We're going to do the prefix match for the full, and also we want to header the X4 prefix matching with hello, start with hello, and with protocol HPS and HTTP. Let me create the routes. Okay, as you can see, the route has been created. The next, let's try long. Try to guess X4, and as you can see, the start with hello, so it should match. Okay, all right, 200. Cool. Let's try it again. Right now we are using the header. The header has hello inside and has word as a postfix. It should also works. All right, we got 200. And let's put like something not work because word here is not start with not ended with D, so it shouldn't work. Let me try to do. So router shouldn't be matched. Okay, all right. So that's the 404. Not fun. Yeah. See, we are the route is working. I will actually want to emphasize that the huge amounts we spending is not actually on building the DSL itself. We actually spend a lot of time to make sure it's compatible with your existing router. So in the 3.0, we actually make the compatible by default. So you're going to still using whatever the router configuration it has in production with no downtime and with no migration, no change. You're just using the compatible. Underneath, we're going to compile your 2.0 series router configuration to the expression based. So you don't see any difference. But if you're advanced enough, if you have tons of like 10K, 20K of router, you want to take advantage of this expression, you can enable it on and you can try those expressions. All right. So with that, I think that's the router demo. I will leave to Michael for next.
Thank you very much, Guanlan. So performance is super important. Like, that's why I'm excited to also introduce OpenTelemetry. Like, understanding that the router was where the time was going is actually possible thanks to tools like OTel and calculating spans of what's going on within Kong Gateway itself. OpenTelemetry, or OTel, is a collection of tools, APIs, and SDKs to help you understand what's actually happening within your software. You can use it to understand what your software is doing, where it's spending time during execution, things like that. Understanding how Kong Gateway is performing is a key part of any deployment. And we're excited to announce extensive tracing support in both Kong Enterprise and Kong Open Source. Like, gone are the days where a customer says, hey, my API is taking too long, it's Kong's fault. No. Enable open tracing. I don't know if you saw the keynote demo this morning. Like, the upstream was taking all the time. We could very clearly see that Kong Gateway was executing very fast. And this is broken down even by what plugins you're using. If you're using rate limiting, this will show you how long it takes rate limiting to execute. There are two ways to get started. You can use the out-of-the-box OpenTelemetry plugin to send spans to any OTel compliant provider, or you can use the OpenTelemetry collector with something like Datadog, or you can use the new tracing PDK that we offer to instrument your own custom plugins. Now, there are a few known limitations today. The PDK is only available for Lua, so if you're using any of the plugin servers for different languages for plugins, you do not have access to tracing. And the Open Tracing PDK does not support all of the observability providers' functionality. It is tracing, it's not metrics, it's not logs. If you want that kind of stuff, you will also need something like the Datadog plugin to ship metrics in addition. Live demo time. So, OpenTelemetry, we're going to start, create the service and the route. So I've just created a service called OT-demo and a route called OT-route. And I'm also going to create the OpenTelemetry plugin. Here you can see that I'm specifying the endpoint to send the traces to. This can be any OTel compliant endpoint. Any headers, here I'm authenticating with Honeycomb. I will be rotating this key very, very soon. And we're saying send the OTel traces in batches of 200 every couple of seconds. That should be all that I need. To go into Honeycomb and start seeing traces appear. And here you can see that I did get OT hello. The OpenTelemetry phase took 0.3 milliseconds. The router, written in Rust, very fast, 99 microseconds. And actually most of our time was in the upstream, 245 milliseconds. That is OpenTelemetry. Like 3 minutes, enable the plugin on the service, and you just get all of that visibility for free. All right, Guanlan, back to you.
All right. The next things I would like quick talk about, if you're not familiar about Kong is a UI, help you to, for example, customize like configuration and monitor Kong deployments. And Kong 3.0 ship with new design and like good user experience. And like there's a quick snapshot like what's the new magic looks like. But like I will go to live demo directly. Okay, as you can see here, that's our new UI for the Kong. All those good stuff, like we made like hundreds of the JavaScript and CSS changes. Most importantly, is we did upgrade the logo. See the logo? Instead of like a white logo, we have like more color on the gray layer. So I would say that's like huge milestone for us. As you can see from the dashboard, you can see there's nice ring, which calls like how long your license will expire, like when remind you pay us a bill. Yeah, and also like you can see all the golden signal here, like total traffic, latency, and also 300, 400, like what will be the latency looks like. So yeah, that's the workspace overview. Like you can get like a kind of like overview of all your services, all your latencies. But if you want to go, hey, I want to see my workspaces, okay? So you can click to each of workspaces. One of the biggest improvements we improve on is the service UI. So if you click the service UI, you can see here, we have the protocol showing up here. We have the tags, we have paths. So if you click like service production, you can see it's nicely aligned with like what are the router associated to this server. You can click it, and you can see nice coloring around like, is this route like get posts, and also what kind of protocol is support, what kind of tag is support. What's even cool about this is if you click the plugin here, you go to the correlation plugins, you can see which service and which routes actually associates with this plugin. You can easily troubleshooting, and you can see what's went wrong, like what kind of plugin configured to what kind of service and routes. If you try to, for example, if you're trying to upgrade the route here, you can click here. Actually, all the services right now, we provide autocomplete. If you want to change services to the dev environments, you just click here, it's autocomplete for you. So those are the nice UI I've been using. Also, I would like to share a secret for all of you folks here today. It's a pro tips, right? Like if I want to enable something, you have to double click, but there's a secret here. If you click here, enable, you can actually disable services using this secret button. So that's just reserved for a power user. So do not tell your friend, okay? And also same applies to the plugins, routes. If you find like the enable, you can actually click here. So disable this plugin. All right, with that, I think that's the demo for the Kong Manager.
Speaking of secrets, that does bring us quite nicely onto our next topic, which is secrets management. This is the final flagship feature that we're going to be talking about today. And secrets management, like what is it? Well, it allows you to store sensitive information securely in external vaults. That could be AWS Secrets Manager, HashiCorp Vault. There's a great talk in here earlier today on that. Google Cloud Secrets Manager. And you can have Kong access those values at runtime. Now, a secret is something that you want to keep away from prying eyes, but Gateway does require it to run. It could be your database password. It could be an SSL certificate. It could be some plugin configuration to connect to a secured Redis instance. No matter what it is, you probably don't want people going into Kong Manager and going, hey, there's the secret, let me just save that for later. So by storing sensitive values as secrets, you ensure they're not visible in plain text through the platform. That means they're not in Kong.conf, they're not in declarative config, they're not in Kong Manager. In addition, using Vault secrets allows you to have per environment configuration. You know, if you've got different database passwords for production and dev and staging, previously you would have had to change that each time you went from one environment to the next. If you use a Vault reference, all you have to do is make sure the right values are in your Vault. You just promote exactly the same config, so you can have confidence that nothing is breaking whilst you change the values. We're shipping with 3 enterprise vaults, AWS, HashiCorp Vault, and Google Secrets Manager. And we also ship an open source environment variables driver as well. So even if you're running Kong OSS, you can try this out. Operators can reference those secrets using an intuitive format, and Kong will resolve those at runtime. You can see an example on the slide of this format. It starts with Vault as the protocol, then the Vault identifier. I've got HCV here, which is HashiCorp Vault, and then just any nested path to the secret that you need. As always, very theoretical. Let's just see it in action. So just like before, I'm going to create a service and a route. I've created a service, secrets manager demo and a secret manager route. And I'm just going to double check that I have a Vault server running. So if I run Vault get, you can see there's currently nothing in there. So let me just put a secret in there. Redis password is demo. I'm also going to start a Redis server and just said require pass demo. So if I go and just try an auth to that, no auth, like this is now secure. Like I'm not just smoke and mirroring this, this actually works. Auth demo. Let's try that again. Auth demo and keys. Okay, I'm authenticated. Let's go back and create a proxy cache plugin. So proxy cache will let you use Redis to store the response from an upstream so that you can return it to your end users faster for subsequent hits. So secrets management plugin create. There's a lot of text there. The proxy cache plugin matches on HTTP code, content type, things like that. But the really interesting part is actually this Redis password, where I say, I want you to look up the HashiCorp Vault. Look in the Redis key and look at the password entry in there. So if I call that went through, and now if I run that again with -i, we can see that the cache status is hit. I'm just going to go back to Redis and delete that and do it again, and this time it will say miss. See, it took slightly longer there because I'm not using the proxy cache. There we are, X cache status miss. Now this plugin could not have connected to the Redis server without a password. The Vault string that we provided definitely isn't the password. You saw me authenticate with the password demo. So this is Kong Konnect, where recognizing that reference, resolving it in the Vault, and then passing that at runtime to the plugin to connect to the Redis instance with the correct password. At this point, I'm going to hand it back to Guanlan. He's going to take you on an architecture deep dive for 5 minutes or so before we wrap up. Thank you, Guanlan.
Yeah, I can bore you with like a very technical things. Like if you are not a technical person, probably like you'll be most boring in 5 minutes you can maths. Right. So first thing is time library. Why time library is the same? Timer is essentially a way in the OpenST, in the NGX architecture. It's like when you're trying to get some sort of like a callback function, you want to just call some specific APIs, or you want to get in HTTP log flush requests out, then you need a coroutine to do that. By doing coroutine in NGX, it require a fake NGX request. Don't ask me why the fake is. So essentially, they were consume like additional memory, and also we're using like additional connection. And actually, on the timer issue, we've been seeing lots of customers, they're hitting the kind of up limits about the timer. What we did is we introduced a time wheel algorithm. What that means, we're gonna using the wheel to reuse some of the timer pool, and when the timer get expired, and will automatically get DQ. So as you can see the difference here, we're gonna only have the fixed amount of timer to get a reuse and reuse. So memory and your latency gonna stay relevant and stable. As you can see from this benchmark we have with the original timer and the new timer. So the blue one is the kind of like new timer. This one is the original timer. So with that, we can see the linear reduction once the timer count increase, because like we have fixed pool, and also on the original timer will drop to the almost zero if we have so many timers to take care of. So that's the first. The second thing I would like to mention is like improving the inner workers communication. What's the inner communication? So essentially in Kong we have like multiple workers. So each worker you can see their proxy traffic, right? So they are pretty isolated. They don't have to care about each other. But what if there has an event happen? The worker need to share with the others, right? So other workers. The mechanism we're using before, essentially, like for example, if you're getting configuration change in this worker. So this worker say, oh, I need to make a router change, which I just mentioned, right? And they're gonna talk to like all of those gonna constantly want to know, like I want, oh, there's a router change, I should make change. The way we're doing that, essentially, we allocates a bunch of shared disks. Each of the disks, there are events associated to it, and like they also have the fixed size of the shared disks. What if like you have so many events happening in your system, and this we run out of slot for shared disk? What will happen? We're actually gonna lose the events. Yeah, so that's the one thing, one flaw of this design. The other thing I would say on the previous event system, each of the events, they have a lock across the worker. So if we're writing to event 1, other worker, if we try to access the events, they will have locked it and they cannot access it until release the lock. The third thing about this advantage of this is actually actively pulling from this table. So hey, adding for every second or so, do you have a new event? Do you have new events? So instead, we're introducing a new pub subsystem inside of our like event system. What that means, like essentially, we're going to allocate a worker. Normally, it's a worker 0 as a broker. Like we have subscriber, we have like a publisher. So we're using Unix sockets with binary protocol. Instead, we are actually actively pushing if we have an event. The broker will actively, proactively pushing to all the subscriber with the events you're interested in. In that case, let me show you some benchmark we did. Think about you have like 10,000 events coming on, and those are the frequency you change. So if you change like 1,000 events, like half second, there's no big of difference. But when the events getting large, those are actually the real number we see from production, from our customers. They have more than thousands, tens of thousands events, and changing very high frequency. In this case, it's 0.1. As you can see, the new events actually conserve almost like double the RPS than the previous one. All right. Last but not least, another important storage change we made. So this is designed for the hybrid and DB-less. Called MDB. MDB is Lighting Memory Database because like we are leaning to the hybrid world, right? So we also have the Konnect. So the hybrid and it's become more and more important. That's also I mentioned before the shared disk, they have lock. The locking actually hurting the performance for hybrid as well. The things we've been introducing using this MDB is MDB. They support transactional, like full ACID, but they also extremely fast because they're mapping the key value into your memories. The good thing about this is like you can see we build a REST MDB library. All the work events they can visit that. The good thing about this I would like to specifically mention is like by leveraging MDB transaction support and also like it can handle very large configuration at ease. Yeah, that's the benchmark result I want to show it to you. So these are the blue one is the one with the shared disk, and the gray one is with the MDB. As you can see, almost like when you're pushing configuration from your CP node to DP nodes, and the performance penalty, like with shared disk, actually you can see is noticeable. And with MDB, is I would say at least like 1/3 or like 1/4 of the performance improvement. All right.
All right, then it's back to me. That was a whistle-stop tour of Kong Gateway 3.0. There are 9 flagship features, dozens of other features that are here to make your life easier. We covered these 4 today. We didn't even get to these 5. Like, these are the flagship features. These are the ones you should really know about. I highly recommend heading over to docs.conkhq.com/gateway and taking a look at the Gateway 3.0 release notes. It's all in there. With that, my slide is not working. There we are. We have run to time, so we're going to get out of the way for the next speaker to set up. But if anyone has any questions, I will be just off to the side here. We'll happily answer them. Thank you for your attention and enjoy the rest of your day.
Thank you, folks.